What's up guys, welcome back to another mathematics video on sequences and series by myself, Kashay. Let's get into it. So today's lesson will have an introduction to sequences and series, followed by a discussion on linear sequences, quadratic sequences, and geometric sequences. And then we'll speak about series, linear series, geometric series, and then a conclusion on what we discussed in this lesson. Let's get into it. So today we'll be exploring the fascinating world of mathematical patterns and their applications in real life. Sequences and series are essential concepts in mathematics with numerous practical applications in fields such as finance, engineering, and computer science. By understanding these concepts, you can gain valuable insights into how things work and make informed decisions based on data and trends. So we start with linear sequences. Linear sequence is an arithmetic sequence of numbers where each term increases or decreases by a constant amount. For example, 2, 4, 6, 8, 10 is a linear sequence because each term increases by 2. Another example would be minus 3, 0, 3, 6, 9, where each term increases by 3. To find the nth term of a linear sequence, you can use the formula a plus n minus 1d, where a is your first term value, d is the common difference, as is the case with this second pattern over here, which would be 3, or with the first one it would be 2, and then n would be obviously the number of terms in the pattern. For example, if we wanted to find the seventh term of the sequence 2, 4, 6, 8, 10, we can use the formula 2, which is our a value, plus n minus 1, which is 7 minus 1, d, which is also 2, because our common difference here is 2. We add 2 each time. And so therefore, the seventh term would be 12. Just to take a look at the image on the right here, just to see how this works. Another way to determine the general term, as is the case with this pattern of 3, 7, 11, 15, etc., etc. We see that the pattern goes up in 4 just by looking at it and seeing the common difference. And so we know that our Tn value must then be 4n plus a certain number. Now what you can simply do is just multiply as you would with a linear equation. Multiply 4 by each term's value. So with term 1, we have 4. We then need to minus 1 to get 3. Similarly, we do it with this next term to make sure. We get 4 times 2, which is 8, so we need a minus 1 again to get this one. 4 times 3, 12, minus 1 again to get this one. And so we're able to figure out that b must be minus 1. And so that becomes our Tn value. Now we move on to quadratic sequences. A quadratic sequence is a sequence where the difference between consecutive terms is not constant, but rather follows a pattern of increasing or decreasing. For example, the sequence 1, 4, 9, 16, 25 is a quadratic sequence because the difference between the consecutive terms are 3, then 5, then 7, and then 9. So it keeps increasing by 2, which follows an increasing pattern in the differences. To find the nth term of a quadratic sequence, we need to use a formula that involves 3 consecutive terms in the sequence. The formula is that Tn, or the value at n, is equal to a plus n minus 1d plus n minus 1 multiplied by n minus 2 over 2c, where a1 is the first term, d is the common difference between consecutive terms, and c is the second difference between consecutive terms. This formula may seem complex, but it can be broken down into smaller parts to make it easier to use. Another method which I personally like to use for calculating quadratic sequences is shown in the image right here. So if we have our pattern or sequence of 5, 18, 35, 56, 81, 110, we see that the differences in each term is increasing by a certain amount, which is in this case 4. To determine our quadratic formula, we know that it must be an squared plus bn plus c. Now to determine a, we simply take this common difference, which is your second difference, and that is equal to 2a. It's a general rule, and so we just divide it by 2 to determine our value of a. So now, using this here with an squared plus bn plus c, we have our value for a, and now we need to figure out b and c. Now we take the difference between our first term and our second term, and that's always equal to 3a plus b. Now, having just figured out what a is from here, we can then rearrange this equation to figure out what b is equal to. Now we've got our value for b. Now we just simply have to figure out c, where we use our very first term 1 value, which is equal to a plus b plus c, which makes sense, right? Because if you sub in 1 here, you get a multiplied by 1 squared, which is just a, plus b multiplied by 1, which is just b plus c. So it's a plus b plus c. And having figured out what a and b are from these two steps, we can then rearrange the equation to solve for c. Now we move on to geometric sequences. So a geometric sequence is a sequence of numbers in which each term after the first is found by multiplying the previous term by a constant, so-called a common ratio. For example, the sequence 2, 4, 8, 16 is geometric because each term is separated by the common ratio of 2, in which the previous term is multiplied by 2 to achieve the next term. To find the nth term of a geometric sequence, use the formula Tn or An is equal to A multiplied by R to the power of n minus 1, where A or A1 is your first term value, R is the common ratio, which we discussed, which would be like 2 in this pattern over here, and n is just your term number. So for example, if we wanted to find the sixth term of that same sequence, 2, 4, 8, 16, etc., etc., we can use the formula to determine the sixth value to be 2, which is our first value, multiplied by R, which is also 2, to the power of 6 minus 1, which gives us 64. Another example, just explaining how the general formula works, is shown in the image here, in case you didn't quite get that. Now we move on to series. A series is a sum of terms that follows a specific pattern. It can be finite or infinite, and it is represented by the symbol sigma, which is just represented or shown as the sum. To find the sum of a series, we add up all the terms in the sequence. For example, the series 1 plus 2 plus 3 plus 4 plus 5 has a sum of 15. There are two main types of series, arithmetic and geometric. In an arithmetic series, each term is equal to the previous term plus a constant difference. So basically, our linear sequences that we had earlier, except instead of there being different term numbers, each term is added to each other. So for example, the series 2, 4, 6, 8, 10 is an arithmetic series with a common difference of 2 between each term. To find the sum of an arithmetic series, we use the formula Sn is equal to n over 2 multiplied by 2a plus, and then in brackets n minus 1 multiplied by d, where Sn is the sum of the first n terms, a is your first term value, and d is your common difference. In a geometric series, however, each term is equal to the previous term multiplied by a constant ratio. For example, the series 1 plus 2 plus 4 plus 8 plus 16 is a geometric series with a common ratio of 2. To find the sum of a geometric series, we use the formula Sn equals a multiplied by 1 minus r to the n over 1 minus r, where Sn is your sum of the first n digits, a is your t1 or your first term value, and r is your common ratio. So if we take another look at the image on the right here, it basically just explains how to find arithmetic series sums and how to find the sum of a geometric series as well. And this also does speak about having infinite arithmetic series and infinite geometric series. To look at the infinite arithmetic series, this might just be some interesting point that you might want to look at and see if you can understand. And for an infinite geometric series, we'll explain that just now. But it's quite simple to see that for an infinite arithmetic series, if it's getting greater in a positive direction and the series just continues to carry on, it'll just keep going to infinity. And if it's getting smaller or getting increasingly negative, it'll just become negative infinity. So linear or arithmetic series. So a linear series is a type of sequence where each term differs from the previous term by a constant value. In other words, the difference between consecutive terms is always the same. Here's an example illustrating this again, with each term differing by 3. To find the nth term of a linear series, which we've discussed, use the formula an or tn is equal to a, which is your first term value, plus n minus 1 multiplied by d, which is your common difference. Again, the formula here in the image on the right just shows you how to calculate the sum of terms using n over 2 multiplied by 2a plus n minus 1d, and how this formula can then be derived to then determine your sum of terms when given your first term value and your last term value. Similarly, to find the difference between two values when given the sums, you can take the sum of your patterns until n and then subtract the sum of the pattern until n minus 1 to determine what your term value at n is. Now we move on to geometric series. A geometric series is a sequence of numbers where each term is obtained by multiplying the previous term by a fixed number called the common ratio. Now we've already spoken about this formula, but let's take a look at how you can calculate an infinite geometric series. So an infinite geometric series occurs when the geometric series just continues to go on without stopping, but your constant ratio has to be within a certain bound for your series to converge and provide you with an answer. Your R value is said to have to be greater than -1, but less than 1, and obviously it cannot equal 0. And so use then this formula where A, being a term 1 value, is divided by 1 minus your constant ratio. So to conclude, we've learned about the 3 types of sequences: linear, quadratic, and geometric, as well as how to find the nth term of each type. We've then also discussed series and how to find the sum of both arithmetic and geometric series. It's also important to understand these concepts because they are used in many real-world applications from finance to engineering. By understanding sequences and series, you can better analyze and predict patterns in data, which can lead to more accurate forecasts and better decision-making. Additionally, understanding these concepts can help us appreciate the beauty and complexity of mathematics. So let's continue to explore this fascinating topic, and we'll see where it takes us in the future. But I hope you've learned quite a bit from our lesson today, understood and maybe learned something new as well, and I'll see you on the next one. Cheers.